Hey guys, Kamizel here with another chemistry video. Today we will be doing acids and bases, part 1, concepts and equilibrium, because this is a huge topic and I'm going to break it up into 3 parts, maybe 4, probably 3. So let's just start by defining what an acid is and what a base is. Acids, well, they're sour, but don't taste them in the lab. Well, you can, but you may die. But YOLO, right? Just kidding. Really, don't taste them. Um, they typically have a hydrogen molecule in their formula, like for example, too strong. Acids HCl and HBr, and their pH. We'll talk about this later. What pH is less than 7. Now bases. Bases are bitter. Once again, don't taste them. They typically have a hydroxide ion molecule, whatever, OH, in their formula, like NaOH, strong base, sodium hydroxide, and the pH is greater than 7. I'm just wondering to myself here, but who found out what they taste like? It's like, oh yeah, acids are sour, oh, bases are bitter. I mean, what scientist just like, hey, give me some of that, I'm gonna lick it. Okay, so that is the common way of defining an acid and a base, that's like the general, but of course in chemistry there are more than one way to do things. So, here are the other two. This guy named Irenaeus came along and said, yo, acids, if you put them in water, an aqueous solution, that's just when put in water, they're going to produce an H plus ion. And then he said, well, yo, I don't know why I'm making him gangster. He said bases will produce an OH minus ion in an aqueous solution, which is, like I said, just when you take that acid or base and you put it in water, acids will produce an H plus ion, bases will produce an OH minus ion. So that's Arrhenius. And then these other two guys, Bronsted and Lowry, said acids are going to donate a proton, which is the same thing as an H plus ion. So they're going to give it to a different element or compound. And if you want to know why a proton is just an H plus, I'm going to tell you. If you don't, just mute me for the next 10-20 seconds. So remember, hydrogen has the atomic number of 1, which means it has 1 proton. And because hydrogen, as it's found in nature, is not an ion, it also has 1 electron to balance off that 1 positive proton. That's literally all that hydrogen is. 1 proton and 1 electron. An H plus ion, H plus, you get the plus by taking off the electron, which leaves you with a proton. So acids donate a proton, which is, well, I guess I should tell all those people he muted, unmute. So acids donate a proton, which is the same as an H plus ion. They are the same thing to a different element or compound, and the one that receives said proton is what Bronsted and Lowry define as a base. Acids donate H plus, bases receive. That's Bronsted-Lowry. Those are the two other ways to define an acid. Arrhenius, acids will produce H plus, bases will produce OH minus. Bronsted-Lowry, acids will donate H plus, bases will receive H plus. Notice he says nothing about hydroxide. He says nothing about OH minus. Cool. Okay, so now we know what the difference between acids and bases are and how to identify them. There are also strong acids and bases and weak acids and bases. And they react differently depending on if they're strong or weak. So to help explain this, let's just look at HCl, which is a strong acid, hydrochloric acid. Here's what it looks like. There's one H hydrogen molecule bonded to one chlorine molecule, HCl. Now, when you add this to water, it dissolves like this. This bond, right here, this bond right here, breaks, and, well, you get an H plus ion and a Cl minus ion because the water dissolved the HCl into the ions. The strong acids dissolve 100%. Every one of their molecules, every one of this HCl molecule that you put in there will dissolve. And that means that there will be more H plus produced because every single ion or every single molecule we put in there is going to dissolve into H plus and Cl minus, which is also called dissociating. And that means there will be more H plus, which means the acid are strong. The acids are strong. Hence, That's why they're called strong acids. If they dissociate, also same word as dissolve, completely they are strong acids, and this is what the solution would look like. You got a bunch of H plus and CO minus ions bouncing around. That's strong acids. What about weak acids? These don't dissociate completely, meaning that there are less H plus ions, which is, why they're called weak acids. So, to see what they do in fact do, let's take a look at hydrofluoric acid, which is a weak acid. So, you got some hydrogen and some fluorine bonded. You add that to water, and you get some of the HF splitting apart. You got some of them dissociating into H plus and F minus ions, like here, 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 and here. But you also have some that don't. Here, here. They stay bonded. Some of the weak acids stay as a molecule instead of dissociating. Some of it doesn't dissociate. So, yeah, that's weak acids. Strong acids, all the way. Weak acids, not. Okay, and bases work the exact same way as strong acids and weak acids, except that, say strong acid NaOH, it's not going to dissolve into Na plus and H plus, it's going to dissolve into Na plus and OH minus. So instead of the H plus ion, you get the OH minus. Instead of hydrogen ion, you get hydroxide ion. But other than that, it's the exact same. So strong bases dissolve all the way into whatever the first element is and OH minus, and weak bases dissolve partially, like this. Okay, cool. Now, equilibrium. Bum, bum, bum. See, I even made it all caps. That's how important it is for this unit. So let's go back to the weak acid, just to show you what equilibrium is. We got HF in here, which means we got HF bouncing around, floating around, just doing its thing all over this water molecule, just having a blast. And when it does this, there's H plus and F minus ions in there that are going to be moving around like choof, choof, choof. They're bouncing everywhere. And as this happens, if an H plus ion and an F minus ion happen to hit each other, then they will come together, rebond, and form a solid HF molecule. So, whoa. Here's initial. You got H plus, you got F minus floating around, and you got some HF molecule. And if two of them hit, H plus and F minus, you got an HF new molecule. Whoa! And at the same time that this is happening, HF molecules are dissolving. Like this right here, this HF molecule will dissolve at the same time that new ones form. So for example, like right here, we got an HF molecule, and it dissolves at the same time that, let's say, an H plus and an F minus ion form. I had to play that over a few times just so you make sure you understand that concept. That as some are dissolving, others are forming. And in the water, for a weak acid or base, you've got H plus ion and F minus ion, or whatever the other part is, and you have solid HF bonded together. And, well, what does that have to do with equilibrium? Well, equilibrium is the point at which, in this case, HF molecules are forming and dissolving are equal rates. That is what equilibrium is. At equilibrium, if one HF molecule dissolves into H plus and F minus ions at that exact same time that bond breaks, a new bond will form between a different H plus ion and F minus ion combining together to form another HF molecule. That's equilibrium. Yeah, I would just make sure you understand that concept, and cool beans, you're good to go. That's all for this video. If you liked this video, be sure to share it with anybody that you think needs help with this subject. And if you have any questions, leave me a comment, check out my website, and yeah, see you next time.